Graphing the sine and cosine functions. We're going to fill out this chart and that graph. You're going to need some graph paper to start with. The purpose of this is to graph the sine function. So we have to fill out this table. How you're going to fill it out is by using your calculator and rounding to the tenths place in each case. So if you type in sine of 0, you know it's going to come back to be 0. Sine 30 is 0.5 and sine 45 is 0.7. Just a matter of filling in this table. Sine 60 is 0.9. Sine of 90 is 1. Sine of 120 is 0.9, and sine of 135 is 0.7. Then we go to 150, that's 0.5. You can be doing these on your own calculator. If you're waiting on me to go back and show the whole table, you can punch them in yourself. This is not a mystery how these values are coming to be. Sine 180 is going to be 0. So then we go back here to 210 down below. Sine of 210 is negative 0.5, and sine of 225 is negative 0.7. Sine of 240 is negative negative 0.9. Sine of 270 is negative 1. Sine of 300 is negative 0.9. And sine of 315 is negative 0.7. Sine of 330 is negative 0.5. And sine of 360 is 0. So filling out the table should not be that strenuous. When you go to graph this, you do not have to replicate the graph paper that's on the screen here. You should know by now how you can change the window of your graph, such as the range X and Y. You should know that this is going to go between 1 and negative 1. I have 4 blocks in there, in between there, so that means it's been chopped up into quarters, 0.25, 0.5, 0.75, and so on. Notice that it goes, you see multiples of 90 on the screen every other line. That means the ones in between them. The first one is 45. Then the second one between 90 and 180 is 135. You're just adding 45 each time you go across. You can make yours different. You can go 1 degree at a time and make 360 hash marks if you want to, but I wouldn't recommend that. Alright, so we have to graph this. So we're going to start with sine of 0 and just put a dot on 0. And sine of 30, notice that I have these chopped up into 45s. So if this is a 45, then that means I'm going 2 marks in between by 15s. So 30 would be the closest to the 45, and that would give me a value of 0.5. So I'm going to make a dot there. Next up is sine of 45 degrees is 0.7. So I'm going to make a dot there. And next up is sine of 60 degrees. Now I have to come back in here and take a look. I have 45, 60, 75. So I'm going to plot. I need to go over to 60 degrees and go up to 0.9. So that's going to be approximately there. And then 90 degrees is 1. So we have part of it completed there. So up to 90 degrees, we're starting at 0 degrees. Sine of 0 is 0. We go up to 90 degrees. Sine of 90 is 1. So we've gone the whole range. So now we have to come back down. We have sine of 120 is 0.9. Now on my graph here, this is 135. So this would be 105 and then 120. So I'm going to make a dot there. And then we have sine of 135 is 0.7. Puts me right on the hash. And sine of 150 is 0.5. Alright, if this is 135, this should be 150 and then 165. So I'm going to put a dot here. And sine of 180, simple enough, is a 0. So we've gone up and then back down through 180 degrees. Now we go to sine of 210. We have 180, so this is 195. This would be 210. And sine of 210 is going to be negative 0.5. So I need to come down here, make a dot. Then sine of 225. If I add 45 to 180, it puts me on that hash mark, so I have to be at a negative 0.7, which is approximately there. And then for 240, if I add 15, I just go over just a little bit, make a dot. 270 is negative 1. I want to go to 300 now. Well, if I add 45 to 270, it puts me here. That's 315. So just behind that, on this mark, would be 315. So 315 would be at negative 0.7. And then we come back. We have 330 as a negative 0.5. So that would be just to the right of that. And then 360 is 0. So we've gone one revolution of the circle, 360 degrees. We started at 0, we went up to 1, we went back down to negative 1, then back up to 0 again. Okay, that completes the requirement for part C, I believe. No, that's part B. From 0 to 360, but C is to extend the graph of the sine function above so that it is graphed on the interval negative 180 to 720. Okay, we can create this without having to do all of these points in between. We don't have to create another table to 720. We don't have to create one back to negative 180. All we need to do is follow what we've done so far, and then use that to go clear through to 720. So notice when we started at 0, we went up to 90, and then we came back and crossed the x-axis at 180. And we have a minimum point down at 270. We're crossing back up at 360, and then our maximum point now should be where? What degrees will our maximum point be at if you follow the pattern? 450, and then it's going to cross the x-axis at what measurement? And it's going to be a minimum at which one? 630, and then back to the x-axis? 720. So graph that out and see if we come out like that. Yep, looks consistent. So what if we went back beyond to the left of the y-axis? Where would our minimum point be at? Negative 90, and then we go up to the x-axis at what degree measurement? Negative 180. So let's draw that. Okay, there is the sine function graph. For the interval negative 180 to 720, describe the values of theta at which the sine function has relative maxima and minima. So let's find some minimum points first. We'll do the minimum. What is the first minimum point from left to right on this graph? Negative 90. That's supposed to be a colon there. There we go. And the next minimum point? 270. And the next one? 630. All right, for the maximum points, The first maximum is what? 90, and the next one? 450. Okay. For the interval negative 180 to 720, describe the values of theta for which the sine function is increasing and decreasing. Start clear over from the left. And I'll try to keep the graph on the screen and still be able to write at the same time. Start clear over at the left. What is the first thing that's happening? You're decreasing. So we're starting at negative 180. And between negative 180 and what value is it decreasing? Negative 90. So for theta being between negative 180 and negative 90, you're going to see a decrease. Okay, what's happening now starting at negative 90? It's increasing up to what? Up to 90. It's still going all the way up. So between negative 90 and positive 90, you're going to see an increase. And I don't think we need to do everything all the way through. I think you get the point after seeing these two, that if you had to list all of them, I think you would be able to do that. For the interval negative 180 to 720, list the values of theta at which the graph of the sine function crosses the horizontal axis. So where y equals 0 is what we're looking for. And where is it crossing the x-axis first? Negative 180, then what? 0, 180, 360, 540, 720. Describe the end behavior of the function. In other words, where do you think this function is going to end? It's never going to end. Does it go all the way to the right forever? And what about to the left? Yes. So we can say that it goes, and I don't have a whole lot of room in here to write, but I'll do my best. This thing is going to go from negative infinity, and that's not an 8, although I'm writing kind of slanted there. It should be negative infinity. There we go. Red. And then up to positive infinity. Now, does it keep the same basic shape, same basic repetition, do you think? Yeah, so it'll keep the same pattern as it keeps going out. That's the simplest way that we can explain that. Based on the graph, is sine an odd function, even function, or neither? Who says odd? You say odd? You say odd? Anybody say even? Okay, he says even. Anybody say neither? All right, it is an odd function, and here is why. The reason why it's odd is because, and if I can do this right here, it starts at 0, and then it goes up, and you can see how it goes down, and it repeats the same pattern. Also, another way to explain it is this. Think, and I'm going to draw this in blue. I think that's the best way to do it. What if you had this? Notice that it's not starting at 0, it's crossing up here. Would this piece over here, if I transposed this piece over here, just whatever marking, beginning and ending you want to put on it, would it translate back over to this side and end up right here at this point? No. You would have to get creative to make it piece up. In other words, it's going to be kind of strange. So it turns out to be an odd function. If it starts at 0 and it is symmetric about the origin, then it's going to be an odd function. Also, another way to look at it is this. I'm running out of colors. Let's go to green. Here's the origin, symmetric about the origin. Does this piece over here match up with that piece over there if you just fold it over through the origin? Yeah, it would. So if I folded this over that way, it would match up. So it's going to be odd. Okay, so based on, okay, we did odd. So describe how the sine function repeats. Okay, so you see the basic thing up here, and I'll do it with the laser. It starts here. Now tell me once it has gone through one cycle, tell me to stop. Okay, so describe how it repeats. If I hit this desk every minute, in some classes I might hit it more times. But if I hit it every minute here, I'm hitting it every minute. That's what I'm using to describe. So how do you describe how this repeats? Every 180 degrees? Every 360 degrees. Yeah. Because this, here to there, is one whole thing. Then it starts over again.